Welcome back, students, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 11, pH determination of solutions, acid base indicators. Again, the first thing you want to do is make a copy of the lab report. You're going to find it on Brightspace. Edit the document as we're going and submit the lab report. The first thing you want to do, again, at the top, you want to put your name and the date in which you are completing the experiment. The direction states that in the box below, we want to write one sentence that clearly describes the goals and method used to complete the experiment, and the sentence should begin with to. So, the objective for today's experiment is to determine the pH of unknown aqueous solutions by using multiple acid base indicators and pH paper, compare indicator color changes to standard calibration curves, and evaluate the accuracy and limitations of each indicator method by calculating and discussing any discrepancies with instruments' pH meter measurements. Again, the objective for today's experiment is to determine the pH of unknown aqueous solutions by using multiple acid base indicators and pH paper, compare indicator color changes to standard calibration curves, and evaluate the accuracy and limitations of each indicator method by calculating and discussing any discrepancy with instrument, pH meter, and measurements. Again, what you want to do is pause the video, write down your objective, and then move on to the next section. We are going to now make sure to fill out the equipment and function table on your lab sheet. So the first equipment we'll be using for today is the 50 milliliter beaker, and the function is it hold each prepared aqueous sample for testing. pH meter measures the precise pH of solutions electronically for use as the reference true pH. pH electrode probe senses hydrogen ion activity in the solution, connects to the pH meter, and must be calibrated. pH buffer solutions used to calibrate the pH meter and verify its accuracy. Universal indicator solution or paper provides a broad calorimetric estimate of pH across the full range for quick comparison. So provide a broad colorimetric. So colorimetric, which means it's relating to color. Colorimetric estimate of pH across the full range for quick comparisons. Volumetric pipette deliver accurate, repeatable volumes of sample and indicator for consistent testing. And the magnetic stirrer ensures homogeneous mixing of indicators and samples so color changes are uniform and reliably observed. So let's talk about the theory behind this lab, some terminology you need to be familiar with. Acids are compounds that can produce H plus when dissolved in water. Again, H plus is also known as the hydrogen ion, which is similar to H3O plus, which is the hydronium ion. Bases, on the other hand, are compounds that can produce OH minus when dissolved in water. OH minus is the hydroxide anion. Acids and bases can be considered either strong or weak. And in order for us to say that an acid or a base is strong, we mean that it completely dissociates, which means it completely breaks apart into ions when dissolved in water. When we talk about weak acids or bases, we say that they have partial dissociation into ions when dissolved in water. The pH of a solution measures how much acid or base is present in the mixture. The pH is a number that can vary from 0 to 14. Now, if the pH is less than 7, the solution is acidic. It contains significant quantities of H plus from an acid. Now, it's different when the pH is 7. When the pH is 7, the solution is neutral, which means that we have equal amounts of H plus and OH minus. And if the pH is greater than 7, we say the solution is basic, which means it contains much more OH minus from a base. Now, we have another definition, which is indicators. Indicators are compounds that can change color in the presence of acid or base, and this is what we will be using today in order to figure out if we have an acidic or if we have a basic solution. So determining the pH. The pH of a solution can be, now you can use the pH by calculating if the concentration of H plus or OH minus is known, approximated using an indicator. We're going to be talking about different indicators. You can also use pH paper that develops a color related to the solution of pH. So as you can see here, depending on the pH, the indicator will have different colors, and measured using a pH meter whose sensor measures an electrical property of the solution that is proportional to pH. So pH is related to the hydrogen ion concentration, and this is the pH sensor with the probe right here. Now, the relationship between pH and the color of a universal indicator. So, if you have a universal indicator, the pH is 7, it's going to have a green color. That's the color for water. Milk will also be greenish. Now, battery acid, the pH is very acidic. So, the color of the universal indicator will be red. So, when the indicator shows red, that means it's very acidic. Versus bleach or drain cleaner, which is a base. Notice pH closer to 14, it's going to be more purple. So, as a quick review, between 0 and 7 is acidic, 7 is neutral, above 7 to 14 is basic. Now, the effect of acidic and basic solutions on litmus paper. So, there are a few types of litmus paper. There is blue litmus and red litmus. Blue litmus paper, again, it changes color depending on the acidity and basicity of your solution. Red litmus does the same thing. And the universal pH paper also has its own color. So, this changes color according to the pH. Blue litmus paper always stays blue in basic solutions, but turns red in acidic solutions. On the other hand, red litmus stays red in acidic solutions, but turns blue in basic solutions. Universal pH paper will turn a specific color depending on the pH of the solution. It goes by its specific colors. All right, so here's the experiment. We're going to have blue and red litmus paper, pH paper, beaker. The chemicals we're going to be using are hydrochloric acid, acetic acid, sodium hydroxide, ammonia, Yamada universal indicator. We're going to obtain 4 clean beakers, labeling them A, B, C, D. We're going to pour 10 milliliters of acid in beaker A, 10 milliliters of acetic acid in B, 10 milliliters of sodium hydroxide in C, and 10 milliliters of ammonia in D. We're going to dip the blue litmus paper in each solution, record what happens for each solution. We're going to dip the pH paper in each solution, record what happens then. Then we're going to place a few drops of the universal indicator in each solution and swirl, and notice what happens to the color. So we're going to start. Here are all the equipments that we'll be using, and let's start with the first one. The data sheet now. So we're going to be putting all these samples in different types of indicators and litmus papers. So make sure to write what is the color of the blue litmus, color of red litmus, color of the pH paper, estimated pH, color of universal indicator. So we're going to start with the first one, hydrochloric acid. So the hydrochloric acid right here. All right. We're going to dip it in the acid and notice the color. Here is the again. It turns Here's the color right here, so we're focusing on it. We're dipping blue. That's the second solution. Notice what happened to the color. Third solution, blue litmus. Oh, look at that. Very blue. Very blue. So the first two were red. See that? Let's focus. Red, blue. You can see the distinction. Blue litmus, right? And ammonium hydroxide, which is a base. Look at the color. Very blue. So blue litmus was red, red, and then blue, blue. So beaker A red, beaker B red, beaker C blue, beaker D blue. So acetic acid and hydrochloric acid, they turn red, and for the bases they turned blue. All right. So that was experiment number one. Now we're going to try red litmus paper and see what happens. So we're gonna take red litmus. Here it is, red litmus paper, and we are going to dip it in hydrochloric acid. Red litmus paper. Red. As you can see, acid will always turn the paper red. Doesn't matter the color. Acid turns it red. And basis turns the paper. Let's see. We're gonna do it first. We're gonna put the look at that base. B for base. Blue. Base becomes blue. Acid becomes red. Look at that. Very good. So it doesn't matter. The color of the paper is irrelevant. The acid will always turn red and the base will always turn blue. Very good. All right, so that was this part of the experiment. Next up, we got red litmus paper. We're gonna dip it in ammonium hydroxide. That was the one that was missing. Ammonium hydroxide. Let's see. Dip it and notice you see the color blue. It's turning blue. And look at that, very blue and now red. So the acids turn red and the bases turn blue. All right, very good. Now here are the results: blue and red litmus paper. So we got blue and red. The red litmus paper, if it's an acid, it turned red. The blue litmus paper, when it's an acid, it also turned red. Let's look at the bases. The bases, the red litmus paper turned blue, and the blue litmus paper also turned blue. Very good. Now let's look at what's gonna happen when we. This is the pH paper now. So this we got a pH paper. We're gonna dip it in acid. Oh, look at that! Turns red immediately. The pH paper, red. Look at that. Red means it's what? Okay, red. It's between 0 and 1, so you can pick any pH between 0 and 1. So that was. So you can write pH is equal to, let's say, 1 or 0. Let's look at acetic acid. Acetic acid is orange. I see it's more orangish. Okay, you could say pH 2, so it's less acidic. All right, and we know acetic acid is a weak acid versus hydrochloric acid, which is in beaker A. Sodium hydroxide is a base. Let's see. It's actually a very strong base. So when we dip it, oh, it's very dark blue. Very dark blue. So you can say this about pH 14. pH 14. So that very strong base. 1 molar concentration. Very strong base. Next up, we got the pH paper for ammonium hydroxide. We're going to dip it. Oh, and it's already there. It's green. Green, but you gotta dip it first to see. Oh, look at that. The it is blue, and it's less blue. You can say pH third, about 13, pH 13. So it's ammonium hydroxide is also 13 or even 14, but it's definitely on the basic side. So this also proves that the first two beakers are acidic and the last two beakers are basic. Very good. So make sure you record all your observations. And then here are the observations again. The acids turned red orange, and the bases are here deep blue and purple. The last thing is the Yamada Universal Indicator. Look at the color of the Yamada Universal Indicator. We're going to take the pipette, take a little bit of the Yamada Universal. You just need to add, one or a couple of drops. Very good. Very good. Look at that. We just keep adding. And the Yamada turns, look at the color of the Yamada for the hydrochloric acid. This, we got to swirl it. All right. And then we're going to do the same thing for acetic acid. Now it's still an acid, so it should give us, let's see what color we're going to get. Again, we're going to add 2 to 5, like a few drops, 2 to 5. All right, 6, 7, 8, 9. Okay, good. Notice the Yamada Universal Indicator gives us, so this tells us that we're dealing with an acid. It's just an indicator. All right, now we're going to do sodium hydroxide to see, are we going to get this reddish, pinkish color? Now the Yamada looks green. Look at that universal indicator. We're gonna, oh, look at that. Nice, beautiful, deep purple color. The Yamada. Swirl, Yamada. Yes. And then we cover it. Then we go on to the last one, which is the ammonium hydroxide. Add a few drops. All right. Look at that. So this also proves beaker A and B are acids. Beaker C and D are bases. Look at that. Make sure to record the color of the Yamada universal indicator. Very good. Perfect. All right, and here are the results. And as you can see, the first two, the hydrochloric acid and the acetic acids are acids, and the sodium hydroxide and the ammonium hydroxide are bases. So the next thing you want to do is in one or more paragraphs, summarize the results of this experiment. Make sure to write in full sentences, avoid using bullet points or sentence fragments. Describe any trends or patterns you observed. Make an effort to support your statements by referring to the theory in the pre-lab discussion. Support your statement with examples from the data. Now, announcement reminders, you're expected to do the following. You've already done the first one, watching the experiment video. 2, make sure to complete the quiz based on the experimental video posted on Brightspace, and make sure to submit the lab report using the given template based on the experimental video. Thank you, and see you soon.